Hi, welcome to the new episode of Startup Strides. Today, my guest is Georgia Witchel. She's a CEO of Mantis Biotech. Welcome, Georgia.
Hi, it's great to be here.
Well, I'm really excited for the episode. I think you're building something extremely cool. I have a lot of questions around your startup and the space you're building in. But before I start with those questions, I'm curious about your background because took the liberty of looking at your LinkedIn and seeing the brief bio, and oh my God, the accomplishments are just so much. And you had a stint in startups. You're pro athlete, just so much. So I'm curious. I mean, I want to give you a chance to walk us through um, your background in your own words. So the stage is yours, Georgia.
Yeah, absolutely. I would say I've like kind of always been really entrepreneurial. I love starting things, and for me, I think a little different than most founders. I got my start actually in like a startup sports team, and so we were kind of starting the U.S. ice climbing team. It's like rock climbing, but you use like a specialized tool, and it's designed for winter. So I did that for around 8 years and had a decent amount of success. And during that period of time, I was also doing pretty well in my classes and I was looking at the acceptance rates at a lot of these colleges. And if you look at the acceptance rate for like, Stanford, Harvard, Yale, it's actually pretty high in like the grand scheme of things. It's like 4 or 5%. So when you're doing really well in your career to take that down step and accept something that is like in the grand scheme of things very high acceptance rate to me seemed like a really bad idea. So I was kind of like, let me what's something that's never been done before, right? Like what's some way that I can differentiate my career and kind of continue this stride. And so I was looking at the bylaws for Harvey Mudd, and I realized that for some reason in the bylaws of Harvey Mudd, they were like one of the few kind of like high ranked colleges that didn't require a GED or a high school diploma to apply. I think it's because they're like a much newer college, so they just like assumed it was implied. And so I was like emailing with their admissions officers and I kind of cut them a deal and I was like, hey, I will go to your school, but you have to accept me as a dropout. And if I wait until my senior year, I'm not going to go to your school. So it was kind of like a now or never thing. Um, and they got back to me and they were like, yeah, we'll totally accept you. Only one condition: we want you to quit ice climbing because we think it's really dangerous. And I was like, I think I've kind of plateaued as an athlete. Like I'll take it. And so I quit ice climbing and I moved to Southern California and I got my undergraduate degree in computer science. And then after I graduated, I went directly into startups. So I took all of that knowledge that I had learned from being an ice climber and I went and I worked for a sports tech startup. It was invested in and like owned by this like Olympic and national champion golfer. And after about a year of working for him, I was kind of like, I like where this company, I like this company, I like this industry, but one, I feel really stupid, and two, um, I think that I would actually make a really good founder, even though like at the time I was like a really early engineer. And so I left and I got a master's in bioengineering from the University of Washington, and I spent a year there working on another startup that I ended up leaving to start this startup. But it was like very much almost exactly the same idea. And just kind of like, I just didn't like use any of the knowledge or anything from the previous startup. But it was like while I was working there, I started to kind of see the problems that I'm having in this startup. And while I was there, I think I raised around like $4 million. And then when I left, I decided that I wanted to try being a solo founder. So I then immediately raised an additional $5.5 million for my next startup, and now I'm running an office out of New York, and things are going really well.
Georgia, in such a short period of time, you mentioned so many accomplishments. It's like a few lifetimes in one lifetime. It's really cool. And first time I'm hearing somebody giving an ultimatum to a college. That's it's very impressive. Honestly, everything you said gave me like 10 new questions to ask, but I want to stick to my kind of like the few questions I had in mind, so I don't sidetrack too much. One thing I was curious about, you started your, really kind of live in this world of high performance, right? Where the performance is absolute. Um, how did this elite competition, like the ice climbing, for example, shape the way you think about building systems in general?
So I think elite competition was not actually the thing that really shaped the way that I think. I think the thing that really shaped the way that I think is that ice climbing is a very, very dangerous sport. It has a very high mortality rate. And the thing that I really learned, it's also an incredibly painful sport. like you do it in the cold. It's similar to like ice skating or like professional ballet where you're just in the cold 24/7. Like my hands and my feet are permanently deformed. Like you can't really tell, but my two front teeth are fake because I like shattered them with an ice pick. I like had like multiple life-threatening falls, and really what you learn is like managing risk and then maintaining like a level set and like staying very, very rational in really extreme situations. So I think like really the thing that I learned from being a pro athlete is like emotional and self-control. And I think that is much more translatable to startups than necessarily like the competition mindset.
100%. One thing I'm curious though, kind of like a chicken or egg situation, right? Is it, were you always that way? That's why you were attracted to ice climbing, or ice climbing made you that way?
I think it's like a seed that grows, right? Like anything you have kind of like a natural. I think like I've naturally been like a lot less afraid than other people, but I think that like the 8 9 years of ice climbing I did definitely took that like small thing and made it very very large. And again, I think I want to stress it's less like that you're not you have to be like unafraid, and it's more so that you have to be able to like regulate your emotions in really extreme conditions.
And that's, it's very much a solo sport, if I'm not mistaken, right?
Yeah, I'd say yeah, it's pretty solo.
A lot of self-reliance, and you have to manage everything. Is there a certain parallel between that and you being a solo founder right now?
Yeah, I mean, I think it was actually my reason for being a solo founder was totally different than my reason for being attracted to ice climbing as a sport. I tried team sports when I was younger, and I I always was just so scared of letting my team down. And that was kind of why I never excelled at solo sports, as I just kind of liked being an independent unit. But ice climbing, like I had like a few partners that I was really, really close with, like from the start. And they're both actually have now become professional ice climbers, which is really cool. They're doing much better than I could have ever done. But I would say like those relationships were actually like very deep, and we had this like deep sense of like camaraderie and teamwork. And then like my rationale for being a solo founder is that I feel like I can think and move faster when I'm not part of a pair. Like I just like I like that I have everything in my own head, and it's like it's much lower risk as a founder to be a solo founder, I would say.
Wow. Wow. This is probably one of my most interesting episodes for sure. Um, your path to becoming a founder was nothing but linear, right? And we tend to see a lot of relatively linear paths. You go to college, you study a certain degree, you find your founder, or you work in some company and then you become a founder. Yours was quite different in many ways. What do you think this non-traditional trajectory gave you that a more conventional one wouldn't have?
Yeah, I think like a mistake that I see a lot of early stage founders make is I call it like the Ivy disease. And it's basically you see these people and it's almost they almost read like they've spent their entire life tailoring themselves for the Y Combinator application. Um, where you're like, oh, let me guess, were you your class valedictorian and you started a club and then you went to an Ivy League school and then you got a 3.0 GPA and then you interned for a big tech company and then you graduated and you worked in big tech for exactly 2 years before starting a startup in that industry with someone that you worked with, and now you want to do Y Combinator because you feel like it's time? You're like, that's crazy. I've never heard that before. And like obviously like this is a great thing to do with your career, right? Like if you want to be a founder, you should absolutely do that because you're optimizing to be the like Y Combinator founder, quote unquote. The issue is the farther you get in your startup journey, the less you have that baseline of comparison, right? Like that whole path to Y Combinator acceptance is like very, very defined. But then as soon as you get into Y Combinator, the template of like the correct way to go about doing things drops dramatically. And with every single step that you like take forward in your career as a founder, the roadmap just becomes like more and more difficult to read. So if you're someone who's really, really good with maps, you plateau at this like pre-series A region because that's when things like really stop getting documented and the competition gets like really, really difficult. And so I think like for me at least, like the advantage to having a non-traditional path is that like I'm actually more willing to take these like big swings because I'm less so comparing myself to this traditional roadmap. Like this is what success looks like.
Such an interesting perspective. now that you say it, it does feel like getting into Vice has become like getting into investment banking. It's more streamlined. It's sort of like there's a not set path, but you kind of know what to expect and how to go about things. Just bringing things back to your startups, you mentioned a couple of different startups. It's in a physical performance space, in software space, and now you're building yours in biomedical infrastructure. How does those experiences shape your thing? Is it quite different in some ways and very similar in other ways? And why did infrastructure become the thing you want to focus on now?
Yeah, absolutely. So I think like my first startup, it was really great to work in hardware. So it was a hardware product. It basically used like SCMG, which was like a type of novel sensor that sat on your skin. Um, and my main problem with that startup was I was looking at ways to basically simulate the product. Because simulating products is the fastest way to like iterate through like design cycles. And I couldn't really find any good human and computer models to simulate the product. So I kind of just like gave up. And then for my next startup, I was also really interested in like human and computer simulations where we were looking at surgical robotics and we were basically looking at like differential physics environments. And we were like, well, if we can make really, really advanced simulations of humans and computers, we can create advanced simulation data sets that can be used to train robotics. And then that we were having a really hard time getting traction because we were basically a deep tech company. And I was like, it's going to take us probably like 3 to 4 years to even ship a product or get anything substantial. And we were under a lot of pressure to make sales right away. So then for my next company, I was like, okay, I don't have the chops to be a deep tech founder solely because I don't have the experience or the resume. Like to be a deep tech founder, you kind of need to be a successfully exited founder or have like a large background of research. And so I was like, well, what if I solve all the problems that I was having at my previous companies? And I was like, what if I made basically like the infrastructure to enable these human and computer models? And I go and I basically find myself at these other companies, right? Like these people who would really benefit from unified data sources and really good human and computer infrastructure. And I establish myself as an infrastructure layer for a future that I'm very confident is coming.
So there's quite a bit of confidence in the future, the direction of the space. Um, I guess now's a great segue to ask about Mantis. What are you building with Mantis? If you had to explain it to an outsider in 1 minute, how would you go about it?
Yeah, so we do the biomedical infrastructure underlying human and computer models. So basically, lots of companies have really, really fragmented and messy workflows to get from whatever it is they're building to whatever it is they're, shipping, be it like product in the consumer's hands, be it some sort of novel medical device, be it some sort of like test or scientific paper. And we've basically noticed that they have a lot of fragmented data sources. And so they have like, and it's not just that they have fragmented data sources, it's that they have fragmented workflows as well. So they'll have maybe like 10 to 15 data sources that will represent a single human in like whatever simulation study design process they're doing. No one's really communicating what the engineers are doing. No one's really monitoring how the data moves from like collection to testing to deployment all the way through like your eStar submission in the FDA process. So we basically come in and we make a ton of infrastructure layers so that we can really effectively unify your data, unify your engineers, unify your engineering process, and you can almost see everything flowing from this like original source all the way through your product that you're shipping, like similar to like how you would watch water flow through a river. Um, so really we market ourselves as like Palantir for biomedical engineering.
You mentioned something about fragmentation, right? And you know, essentially what you're saying is, engineers, scientists, regulatory teams, they essentially work in silos, right? And I feel like it's not the first time I'm hearing about that, the issue of silos. And I feel like everybody knows that they're very inefficient. So my question to you is why those silos still persist?
Because communication is one of the great challenges of humanity, right? Like the reason that we as humans have an evolutionary advantage is because we're great communicators. Um, but to that extent, like it is the greatest challenge of growth is communication and getting everyone on the same page because everyone works differently. Everyone is competing against each other. Everyone has different workflows. Like I would say basically like competition is fundamentally at odds with this idea of like single unified fragmented work or single unified workflows. Because if everyone could follow the same workflow and there was like a template for how everyone should communicate and manage their data, there would be no competition. But competition is how you gain a competitive edge. So it's basically like companies will do something different, they'll gain a competitive edge, and then they're like, okay, well, now none of this software that works for them works for us because we do it differently, we do it faster, we do it better. And so like we basically make ways of we make software that solves that problem.
So the process itself, in a way, becomes like an IP for all the companies, right? This fragmentation, this complexity of the process.
Yeah, like companies' workflows are part of their IP. So it's like that's why they're all siloed. And then it's also like, I mean, it's really difficult to communicate across silos. If I know everything there is to know about chemistry and I'm a chemical engineer, it's really difficult for me to communicate with someone on the business side.
And who feels these problems like the strongest? You mentioned working, experiencing yourself, but let's say in a typical company, as I'm asking it as somebody who's not very familiar with the space, who would feel this pain the most, and who doesn't really feel it but probably should feel it?
Yeah, so the people who feel this pain the most are people who work in computer science adjacent fields. So that's biomedical engineers, it's chemists, it's pro athletes, it's anyone who does some sort of like human based optimization, but doesn't have a traditional background in computer science. And so I think a great example of this is that a lot of doctors will design medical devices. A lot of doctors have also never taken Calc 3. And most people are really surprised by that because everyone who's making software right now and tools for biomedical developers is assuming that they are a very, very competent computer scientist. And in reality, that's not true. So there's this expectation that, like, oh, they'll just look at all of their kind of like data sources and do all of their simulation correctly because they're so smart as a doctor, they must understand computers. And that's wrong. And it's causing these doctors a lot of pain because they're basically trying to do this thing that like they're not trained to do, they don't want to do. And it's making these like very, very bad point solutions. So those are the people who like feel the pain and want to buy our products to solve it. I think the people who like feel the pain and don't realize that they want to buy our product to solve it is actually engineering managers because we're also very good at determining like which engineers are most effectively moving data. And if you're effectively moving data, you're also effectively moving product, right? Like if you're effectively doing biomedical simulations for a medical device, you are an effective biomedical engineer. So we can actually help these managers tell which of their like subordinates are most effective at their jobs.
So now that you are essentially bringing this simulation, this bench testing, regulatory evidence, everything into one single workflow, right?
Mm-hmm.
Is it just the efficiencies that changes, or like what essentially you're intending to change?
Yeah, I think it's more than efficiency. I think we allow people to make insights that they wouldn't normally be able to make, and we allow them to move a lot faster. So we actually are able to change the way that people are behaving. For example, like when all of your data is in like this singular source, you can actually see the relationships much better, and that allows you to be a much better engineer.
Got it. And one thing I'm curious about every time people build in this very complex spaces is the industry and the space itself tends to be quite conservative in many ways, right?
Mm-hmm.
They're not very open to this very innovative ways of doing things. And as you said, sometimes the process itself is part of the IP, so they don't want to, get on a unifying software layer for everybody, right? So how do you think about automation in a domain where mistakes are expensive and the trust is kind of everything?
Yeah, I think the fact that I have enough, like I have a lot of experience in this space. So for a lot of people, like when I show up to a client call with someone in the biomedical engineering space, I'm not some 19-year-old kid who just rolled out of like Princeton with half a degree in computer science. Like I have years of experience in the industry. I've shipped products before. I've worked with engineering teams before. Like I kind of understand them, and I'm able to communicate with them on their level. And so I think that really quickly like builds a relationship of trust that kind of gives us a competitive advantage as a startup.
Got it. Just as a follow up to that question, you said you participate in this calls. How do you sell infrastructure in an industry that's kind of risk averse and regulated by design?
Yeah, I think our like advantage in sales is that we as a company are very, very good at knowing what problems companies have that they're not publicizing. So all of my sales, I usually go in and I'm like, I think you're probably having this problem, right? And they're usually pretty surprised because they're like, well, we're not publicizing that. Like, how did you know? And I'm like, well, to me, it's very obvious because I understand the problem space. And so I think that's really helpful to lowering their risk aversion because they don't feel like they're taking a risk anymore. They already feel like I like understand the problem from the inside.
That's very interesting. So it's not a kind of like a random cold discovery call, right? It's actually coming in with insights, and they're like, okay, this person understands it, so they're more likely to buy it. On a more macro level, do you think regulation and this, is slowing down innovation, or do you think it's actually kind of helps to expose us with internal processes?
I absolutely think that regulation is slowing down innovation. But I like that's just kind of like the move fast and break things mindset. Like you in biomedical engineering, you can't move fast and break things because you're breaking people.
Yeah,
Um, but yeah, absolutely. Like the eSTAR submission report, FDA approval is slowing down the development of novel drugs. Probably in a good way though, because it's hypothetically in a good way. It's stopping drugs that were innovated a bit too fast from hitting the market.
yeah, fair enough. I'm not going to say if, I'm going to say when Mantis works as intended, because I see the desire and the focus you have. I'm sure it's going to work out just the way you want it. What category does it create that doesn't quite exist yet?
Yeah, so our end goal is that anyone can make a medical device, right? Like anyone can move into these fields. So we're basically just kind of breaking down these issues of communication, right? Like I'm sure that if I could perfectly communicate with someone who's an expert in drug design, I could probably be a much better drug developer. So the end goal here is kind of just like clarity of communication across an organization and the ability of non-technical people to do very technical things.
Expand the capabilities of everybody involved, essentially. We are coming towards the end of our episode, so I'm going to ask more reflection-based kind of questions, if you don't mind. So I guess looking back, what part of your background do you think prepared you most for this moment, what you're doing right now, even though it didn't seem relevant at the time?
Yeah, I would say it was absolutely like growing the U.S. ice climbing team and growing like a very small sport in America to something much larger in America. Um, Specifically in the areas of like there are a lot of days when people are like, "What are you doing?" And you just kind of have to be like, "I'm building a sport. I'll see you later." And also in that like you kind of just so it's like the one you just like, can't really care what anyone is thinking. And two, like you have to be willing to shoot the gap and like you really have to see the future on like an 8 or a 10 year horizon. If you're thinking about what you're going to be doing next year, you're not thinking on the correct horizons.
That's very cool. And also, I feel like personally, I think, doing something so niche in some ways helps you develop this narrative building abilities that you can actually like explain what you're doing. And the same thing applies to startups too, because sometimes you're building in spaces that very few people truly understand what you're doing, right? But you have to be able to sell it to essentially a large group of people to be able to get funding and etc. I guess my final question to you would be, what excites you most about the future of biomedical development that's not getting enough attention right now?
Differential physics by a long shot. If anyone is looking into what NVIDIA is doing with differential environments and soft body simulation, I think that that is absolutely going to be a game changer for robotic surgery, data set generation, human and computer simulation. That's just something that deeply excites me.
Georgia, this was a fantastic episode, probably one of the most interesting ones I've made. Thank you so much for your time and insights, and I wish you tons of luck with Mantis.
Yeah, thank you. Yeah, thanks for having me on. It was a really great interview.